All right, writing an equation in vertex form given standard form. So you might have noticed when we were completing the square that it looks like vertex form. That's because vertex form, which is y equals a times the quantity x minus h squared plus k, has that perfect square trinomial in it. So we will convert a quadratic from standard form to vertex form by completing the square. Now, in our last example, when our leading coefficient was anything other than 1, one option is we could have divided the equation by it because we were solving. But in this example here, I'm not solving. This isn't equal to a number. This is equal to y. I'm just converting, so we have to go with that first method, which is factoring that a value out. So we're first going to start by moving over our constant so we can make the right side a perfect square trinomial. So before we make the right side a perfect square trinomial, we're going to factor our a value out because, again, it's a lot easier to do when our a value is 1. So we add 5 over 2 squared, which is 25/4. But we actually have -2 times 25/4. So really what we added was 25/2. So we're going to add that to both sides. So on the left-hand side, I'm sorry, -2 times that. So actually we added a -25/2, not a positive, because we multiplied that by -2. So on the left-hand side, -25/2 minus 1 is -27/2. On the right-hand side, this quadratic factors to be the quantity x minus 5/2 squared. So we're almost there. We right now have the a times the quantity x minus h squared. We just need to move our k back over. So we add 27/2 to both sides, and we end up getting the equation y equals -2 times the quantity x minus 5/2 squared plus 27/2. Now this is very ugly because of the fact that our b value was not an even number, right? When our b value is an even number, dividing it by 2 is easy to do. But since our b value here is an odd number, when we divide by 2, we get a fraction, we get a decimal. So when we square it, we get a fraction again. So it ends up providing us with not integer values for our coordinates of the vertex, but that's okay. Fractions are numbers too. So now let's graph this. Our vertex is at 5/2, 27/2, which if you're more comfortable with decimal form, 5/2 is 2.5, 27/2 is 13.5. So our vertex is going to be a little bit off graph here at 2.5, 13.5. And since we were given the equation in standard form, let's use that information, and that y-intercept is 0, 1 with the symmetric point. So we can get this quadratic graphed. We need at least 3 points, and we'll pretend like I graphed that better, and I actually went through that point to get our quadratic.